The periodic table works as a scientific chart that organizes all known chemical elements in a structured and logical way. Each element is placed according to its atomic number, which is the number of protons in its nucleus, making the table a map of the building blocks of matter. The layout reveals repeating patterns, called periods, which explain why elements in the same column share similar properties and behaviors. Rows on the table are called periods, and they show how electrons fill shells around an atom's nucleus in a regular sequence. Columns are called groups, and elements inside them have the same number of outer electrons, which explains why they react in similar ways. For example, the noble gases in the far right column barely react with anything, while the alkali metals on the far left are extremely reactive. The design of the table also helps predict how elements will bond or interact to form compounds, guiding scientists in chemistry and physics. For instance, by looking at position alone, you can often guess whether an element will form a solid, liquid, or gas under normal conditions. The table even shows trends such as increasing atomic size, rising ionization energy, and changes in electronegativity across rows and columns. Newly discovered elements are placed into the table according to these same principles, making the chart a constantly evolving but reliable tool. Students, researchers, and professionals use it as a universal language of chemistry, bridging laboratories and classrooms around the world. By compressing a vast amount of knowledge into one structured design, the periodic table allows us to understand matter itself more clearly. In many ways, it is not just a chart, but one of the greatest scientific tools for exploring how the universe is built. If you enjoyed the video, give it a thumbs up, comment, and share it with your friends. Don't forget to subscribe to our channel and hit the bell so you never miss a new video.